The International Space Station, or ISS, is a shining example of human ambition and ingenuity. Orbiting Earth, this remarkable structure stands as a testament to what we can achieve when nations unite for a common goal. The ISS is a symbol of international cooperation, bringing together the best minds and resources from around the globe. It is a marvel of engineering, a testament to our ability to push the boundaries of technology and explore the cosmos. The ISS is not just an empty shell, it is a vibrant hub of scientific research. Astronauts from diverse backgrounds live and work on the station, conducting experiments in a microgravity environment. The knowledge gained from these experiments benefits humanity in countless ways, from advancements in medicine to a deeper understanding of our planet. The story of the ISS is not just about technological prowess. It is also about the human spirit. It is about overcoming challenges, forging partnerships, and daring to dream big. It is a story that continues to inspire generations to come, reminding us that the sky is not the limit when there are footprints on the moon. Before a single piece of metal was launched into space, the International Space Station began its life on drawing boards and in the minds of visionaries. The 1990s marked a pivotal period of design and planning, where the ambitious concept of a permanently inhabited space station took shape. One of the key decisions made during this phase was to adopt a modular design. The ISS would not be built and launched in one go. Instead, it would be assembled in space piece by piece, like a giant jigsaw puzzle. This modular approach offered significant advantages. It allowed different countries to focus on building specific components, leveraging their unique expertise. It also provided flexibility for future expansion, enabling the addition of new modules and capabilities over time. The design and planning phase laid the groundwork for the monumental construction effort that would follow. It was a testament to the power of collaboration, as scientists and engineers from different nations came together to share their knowledge and expertise, setting the stage for a remarkable feat of engineering. The year 1998 marked the beginning of a new chapter in the story of the ISS, the assembly phase. In November of that year, a Russian Proton rocket carried the Zarya module into space. This marked the first piece of the space station to reach its new home in orbit.
Zarya, meaning sunrise in Russian, was a fitting name for this module. It was tasked with providing initial power, propulsion, and orientation control for the fledgling space station.
A month later, the stage was set for the arrival of the first US-built component. Space Shuttle Endeavour embarked on a historic mission, carrying the Unity module to rendezvous with Zarya in orbit. Unity, as its name suggests, served as the connecting node for subsequent modules, playing a critical role in the station's expansion.
Over the next 13 years, a complex ballet of launches and spacewalks unfolded. Space shuttles delivered astronauts and modules from the United States, while Russian Soyuz spacecraft ferried crews and supplies. Each mission added a new piece to the puzzle, gradually transforming the ISS from a collection of modules into a sprawling orbital outpost.
The construction and operation of the International Space Station is a testament to the power of international collaboration. It's a shining example of what humanity can achieve when nations set aside their differences and work together towards a common goal.
5 space agencies representing 15 countries participate in the ISS program: NASA from the United States, Roscosmos from Russia, ESA, which is the European Space Agency, JAXA from Japan, and CSA from Canada. Each partner brought its unique strengths and resources to the table, making the ISS a truly global endeavor.
The United States, with its expertise in human spaceflight and advanced technology, played a leading role in the station's design, development, and assembly.
Russia, with its long and storied history in space exploration, contributed its powerful rockets and reliable spacecraft for crew transportation and cargo delivery.
Europe, through the European Space Agency, provided essential modules such as the Columbus Laboratory and the Automated Transfer Vehicle, or ATV, for cargo resupply.
Japan, with its prowess in robotics, contributed the Kibo module, a state-of-the-art space laboratory.
Canada, known for its expertise in robotics, provided the iconic Canadarm2, a robotic arm that plays a vital role in station assembly and maintenance.
The International Space Station is not a static structure. It requires constant care and attention to remain operational. Like a ship sailing the vast cosmic ocean, the ISS needs regular resupply missions to deliver essential supplies, equipment, and experiments. These resupply missions are carried out by a combination of government agencies and private companies. SpaceX, with its Falcon 9 rocket and Dragon spacecraft, and Northrop Grumman, with its Antares rocket and Cygnus spacecraft, play a crucial role in delivering cargo to the station. But keeping the ISS running smoothly involves more than just delivering supplies. The station requires regular maintenance to ensure that all its systems are functioning optimally. This includes tasks such as replacing aging components, upgrading software, and conducting spacewalks to repair or replace external equipment. The ongoing operation of the ISS is a testament to the dedication and expertise of countless individuals on Earth and in space. It is a 24/7 operation, with teams around the world working tirelessly to monitor systems, plan missions, and ensure the safety of the crew.